All right, now I'm going to look at equations involving decimals. All right, I'm going to show you how to clear the decimals, but then I'm going to say this is virtually unnecessary. Even if you know how to clear decimals, you typically don't. Okay, you typically just go ahead and work it with the decimals still in there, because you are allowed to use a calculator, and calculators are designed to work really well, to deal with decimals really well. So this is with clearing, and then I'll do it again without. Okay. All right. So the idea of with clearing the decimals is you look at all the numerical parts, and you count how many look at how many places are to the right of the decimal. At most, one place is to the right. At most, one place to the right of the decimal. Okay. If one of those numbers had two places to the right of the decimal, that would change what it took to clear the decimals. So this tip is what I'm going to use. If you multiply a number by 10, it moves the decimal point one place to the right. Okay. If you multiply by 100, it moves it two places to the right, and so on. So here, there's one place to the right of the decimal. I want to multiply by 10 everywhere. So I'm going to do 10 times everything on the left side and the right side. Get rid of these here. So 10 times 1.5 turns out to be 15. 10 times 2 is 20. 10 times 7.5 is 75. So I now have an equation that doesn't have decimals in it anymore. So I'm going to start that regular solution process. I'm going to add 20. And I'm going to wind up with negative 15x equals 95. Then I'm going to divide by negative 15 on both sides. And I'm going to wind up knocking out the negative 15, being left with just x here. And then I have to do 95 divided by 15. It doesn't go in there evenly. I'm going to get a negative number. So let me see. If I divide by 5 on both, I get a 3 on the bottom, and 5 goes into 95 19 times. So I'm going to wind up with negative 19 thirds when I'm finished. Okay. All right. So again, on this one, I'm not really forcing you to do this. This is totally optional. You really can get by just as well without. For instance, if you had that equation to start with, what you would really do is just add 2 to both sides. You don't even have to know that the decimals get lined up, because you're going to use your calculator to do the calculation. You just had to know to add 2, and then the calculator gives you the 9.5. All right, and then I need to get rid of negative 1.5, so I'm going to divide by it on both sides. And I'm going to wind up with x equals 9.5 over negative 1.5. Okay. And this one I'm leaving as a fraction because the denominator of the fraction turns out to be 3. So that means that decimal doesn't terminate. It keeps on going forever. So it really doesn't work well in decimal form. So I would let my calculator do this. Once it gave me the decimal, I would change it back, and I would wind up getting this problem right here. So the decimal I would get, it would look like this. It would be negative, let's see, it would go in there 6 times, and then 0.333, and it would keep going. So you don't want to round, but you got to be able to type it into the computer. So that you would change it back from decimal to fraction, and it sometimes changes it to a mixed number in the middle, like mine does. Mine changes it to this, and then there's a button that'll change it back to the normal fraction idea. And I would type that in just like I got over here. Okay. All right. So what I'm saying again is, on fraction problems, it really pays off to try to clear the fractions. But on decimal problems, I don't really care at all whether you clear the decimals. I don't think it's necessary to get it right. People do just as good without clearing. So I would actually propose that you don't clear in most instances. So I could multiply through by 10, but I would recommend you just take away 1.7 from both sides, 1.7x from both sides. Then you'd get 0.8x plus 3 equals negative 6.6. All right, next, you would just subtract 3 from both sides. Okay, when you do that, you'd get 0.8x, 0.8x equals negative 9.6. Okay. Then after that, you would divide by 0.8 on both sides, and you would get x equals, and then it would do this work for you, and it would turn out to be negative 12, and you're done. So it's very quick and efficient to do without clearing the decimals. Okay, let's do one more, and we're not going to clear the decimals. We're going to distribute, get 0.25m, then 2 times 0.25 would be 0.5 or 0.50, you might be thinking. Then distribute the negative 0.15. So you'd have 0.15m, negative 0.15m, and then negative times 3 would be negative 0.45. And then I didn't clear the fractions. I just distributed it all, so I'm just bringing down a 4 when I get finished. Here, if I had cleared the fractions, it would take me multiplying through by 100. So my numbers would be really quite large. All right, so at this point, I'm going to combine my like terms. 0.25, 0.15 would be minus 0.15 would be 0.10 or 0.1m. Okay. And then 0.5, take away 0.45 would be positive 0.05, and that would equal 4. All right. At this point, I would subtract. Sorry, my dogs hadn't been played with yet. Okay. I would subtract the negative 0.05 from both sides. I'd have 0.10m. And then on the right, when I do that, I'd have to borrow from the 3, making that 10, borrow from that, making that 9. I'd have 593. You wouldn't have to go through all that because you should just be using your calculator to do 4 minus 0.05, or just think about it to get that. All right, and then divide both sides by 0.10. And when you do that, you wind up with m equaling, and then over here, after you work that out, you wind up getting m equaling 3. Let's see. I have to do it by hand. I don't have my calculator, so let me just do one thing real quick. So I would wind up getting 39.5. You would just type that in, and you'd get that 39.5. Okay? So clear fractions, learn to do it, try it, see if you don't think it speeds things up a little bit. With decimals, probably easier to not clear and just go ahead and work that out. Okay?